Yeah, so this keyword, if if you look into the online forums, etc. So the most active forums related to JavaScript is always related to the this keyword, and people spend hours figuring out why this is behaving this way, right? So that's why I decided to keep this session, and hopefully if we'll be attentive for next 15-20 minutes, so 80% of those questions will be able to answer by just looking into the code. Okay, so I'll encourage everyone to participate and to use chat box as much as possible. So I'll keep asking some questions, and if I keep getting feedback, I think that is a bit encouraging for me. Okay, so are we ready to start? So we can type yes, no, sure, something in the chat box.
Sure, yes.
Wow, great, thank you. Okay, so JavaScript gives us this keyword, which is very flexible and very powerful. Okay, and there are just couple of rules, and to be specific, there are just 6 rules and one global concept. If we understand that, 80% of the confusions related to this will really uh, sound really simple to us. So we'll go to rule 1 first. Okay, rule 1. Okay, so the core concept is that there are 2 types of functions. First of all, just so that we are all in the same page, we have these regular functions where we use the function keyword, function name, opening and closing parenthesis, okay, and then curly brackets to for the body of the function. And similar thing, but with a variable to which we assign the function. So these are examples of regular function, and this is an example of arrow function. So in arrow function, we basically don't have the keyword function. Okay, so we just have our parameters here and a fat arrow function, which is an equal to um, and an angle bracket and and a body here. So one thing about arrow function is that if we just have one argument, we can skip the opening and closing bracket. And if we just have, and it has something called explicit return. So if we don't even need to write this return keyword, and for that we have to remove this curly brackets. So this basically means this is a function which takes in an argument called number and returns number multiplied by 2. Okay, so this is arrow function. Okay, and another concept that we'll be talking a lot about is function declaration and function execution. So here basically we have declared the function, we have written the body of the function, and here we are calling the function. Okay, so with function name and opening and closing parentheses, we are basically invoking the function or calling the function or executing the function here. Okay, so let's go to rule 1. So the rule 1 is that uh, for all regular functions, all the functions which are not arrow functions, the keyword this points to, so where the keyword this points to is entirely determined by how the function was called, how the function was invoked. Okay, so for example, in this code, we have a function called say hello, which is a normal function, regular function, and it contains the keyword this. So say hello uses the keyword this. So which line here will determine where this will point to in say hello functions whenever say hello is invoked. Hmm. So we have this function here. So, and it uses the keyword this. So which line here will determine the value of this? you can chat your answer in the chat. 38 and 39, correct? Because here is where we are invoking the function from, right? So this is the place from where we are executing the function. So the value of this will be determined totally by how we call it here. Okay. And if and then the first rule is if we simply execute a regular function without implicitly or explicitly binding this to anything, the this points to the global object. And in browser, the global object is the window object. So here we are simply invoking the function. We are simply invoking a function without explicitly or implicitly binding to anything. Okay. So here the this will always point to the window object. So here in the console, we can see that both the this is pointing to the window object. Okay. And now, for example, if I take this goodbye, okay, and if I call it, say, for example, inside say hello, okay. So we have a function called goodbye. By the way, it doesn't matter if it's a function declaration where it is placed, but still I'll keep here to make it more readable. So we have a function read by, goodbye, and it uses this. And we have another function say hello. And if I call say hello, say goodbye will be invoked. Okay. I try to keep the function names as simple as possible. Still, it sounds a bit, uh, um, tongue twister to me. So what will this inside say goodbye point to when I invoke the function from line number 39? Or maybe what will this here point to? Can anyone guess? I mean, how much we listen more than that, it will penetrate in our mind if we answer, and no answers are wrong in my opinion. They all take us somewhere. So, okay, let me break down the question. So this in the goodbye will be determined by which line of code? 31, 36, or 39? So so we have a this inside say goodbye that will be determined from the line from where say goodbye is invoked. Okay. And say goodbye is invoked from line number 36. So line number 36 will determine the value of this. And since it is simply invoked without explicitly or implicitly binding the this, so it will point to the window object. So if we save it, we can see that all the this here is bind to the window object. Okay. So this is rule one, that if a regular function is simply invoked, it points to the window object. As simple as that. Okay. Now let's go to the rule two. So here is rule two. And rule two is about implicit binding of this. So when a method is called as a property of an object, so if a function is attached to an object and it is called by object name.functionname syntax, that this points to the object to which the function is attached. Okay. So for example, this is a function called say hello. Again, a very simple function, and it prints hello and this dot name. Okay. And we have a very simple object called John. Okay. And John object has a property called name, age, and a function called say name. Okay. And James too is an object. It has a property name, age, and a say name, which again is a function which just logs my name is and this dot name. Okay. So now here we are calling the say hello function, for example. So we are calling the say hello function, and we are using a dot before that and an object name before that. So we are calling James dot say hello. Okay. So where will this in say hello point to? This will always point to the John object because we have we have attached this function to the John object, and we are using John dot say hello to invoke the function. So again, our core principle applies here, that the way we invoke the function, we are not simply calling say hello, but we are invoking it with the name of the object. That's why this say hello, any this inside say hello will point to the John object. Okay, is this implicit binding concept clear to all of us? Hmm? I'll assume that as yes. Okay. Okay. So now let's go to rule 3. So I'll again reiterate once. So rule 1 is that if we simply call the function, it is always, this is always points to the window object. Rule 2 is of implicit binding, that if we use object name.functionname syntax and function is attached to that object, then it always points to that object using which we are invoking it. And now let's go to the third rule. Yeah. So the third rule is explicit binding of this. So when we call a function using the call or the apply methods, then this refers to the value passed as the first argument of the call or the apply function. So here we can see that again, we have a very simple function, say hello, and it basically logs out hello and this. And we have two separate objects, John and James. So instead of calling the say hello simply like this, just calling say hello, this is simply calling the say hello, which will bind this to the global object. We are calling it this way, say hello dot call. And the first argument that we are passing is the name of an object. Okay. And here as well, we are calling the same method say hello, but we are calling it with the John object. Okay. So if we clear the console and save it, then we can see that both the this. So when the same function is invoked from line 24, the this points to the James object. And when we call the same function from line number 25, the this points to the John object. Make sense? Okay. Okay, now let's go to rule number 4. So rule number 4 is the hard binding of this using the bind method. Okay. So what happens with the bind? Bind basically creates a new function which hard binds the function to the object that we have specified. So we have a function called say hello, okay, which basically logs hello and this dot name. And we have a separate object called John, and it has a few properties, name and age. And now we create a variable called John say hello, for example, and we invoke the say hello function with the bind method and pass in the John object. Okay, so we get a new method, and that is hard bound. So all the this in this method, the body of this method, is now hard bound to John object in this new function. So if I clear the console and if I save it, or maybe reload it. Yeah, so we can see that the when I invoke the say hello function, this what I get back is the John object. Okay. Is it getting too much? I mean, um, is it too much of information? No, actually, it's just 6 rules. Okay, and just 6 rules. If we understand, like we know, uh, almost 80% of the, 80% of where this is pointing to, we can just look at the code and point it out. Okay, I'll go through all of them very quickly again. So now the rule number 5. So let's go to rule number 5. So rule number 5 is the way of binding this with the new keyword. Okay. So when a function is called with the new operator, it gives us a brand new object, and the this refers to the newly created object. Okay. So for example, I have created a very simple function here called person. It takes in a name, for example, and we basically use this, and we set this dot name to the name that was passed, and then we attach a function called say hello to this, and that basically logs out just hello, this, and this dot name. Okay, so this is just a regular function, nothing more than regular function in which we have used this a couple of times. But when we call it with the new keyword, okay, so this method, when we have invoked it here in line number 18 with the new keyword, it gives us a new, um, let's say, object, hmm, constructor object. And this object, if we call say hello, this function say hello from John object, then this dot name is always bound to, basically this is bound to the John object. So this basically creates a new function in which uh, this is specific to John, and all this value with this is set to John basically. So if I type john.say hello and I save it, okay, yeah. So basically, we can see that this now points to the person, but the name is set to John, and whatever this is specific attached to the John object. So whenever we use John dot the function name, we are sure that we are uh, using this particular object which is newly created. Okay, so this is the 5th rule, and this was the last rule, I think, related to the regular functions. And now the 6th rule is just for the arrow functions. So regular function had 5 rules, and the arrow function has just 1 rule. And the rule of arrow function is that the arrow function, the fat arrow function, does not bind this at all. Okay, so in arrow function, this keyword behaves like just any other variable, and it gets lexically resolved. It so it is determined by where the function sits lexically, where it is written lexically, where it is written physically. So for example, when we were talking about regular function, so where it was written, where the regular function was written was not that important for us, but how it was called, right? How it was invoked, that was more important to us. But in case of arrow functions, where it is written, okay, where the arrow function physically sits, that is most important to us, not how it is called, not from where it is called. Okay, so basically it will keep finding it lexically, like into its parent scope. If it's find if it does not, then it will go further up. So it will try to lexically resolve this keyword like just any other variable. Okay, we'll look into an example, so hopefully it will make a little bit more sense. So yeah, so here I have created again the same very simple object, and I've intentionally kept the example simple so we can focus on the concept and not the complexity of the problem. Okay, so we have a simple object John with property name and age. Okay, and we have a function, and I've named it say arrow hello because it's an arrow function. Okay, then a regular function say regular hello. Okay, and then we have a function called say regular name, which is a regular function. Okay, now this time, everyone has to participate. Okay. Okay, so here in this function say regular name, I'm using make the keyword this. Okay, so which line here will determine from where the this I mean, which line in the whole source code will determine the value of this in say regular name? 42. Thanks, James. So yeah, since we are invoking it from line number 42, um, uh, the this keyword inside say regular name will point, this line will basically determine how, where this will point to. Okay, and I have used the call method and the John object as the first parameter of while invoking the say regular name. So it is quite obvious that the this will point to the John object. Okay, great. Okay, now there is another function say regular hello. Okay, so again, since this function is getting invoked here, so line 34 will determine what the value of this inside this function would be. And since we are simply invoking it, we are not explicitly binding it with call, apply, bind, or anything, and we are not using any property name in front of it, right, any object name, so it will bind to the global object. Okay, and now another is say arrow hello, and again we are invoking here. So in the arrow functions, basically where the arrow, the body of the arrow function sits, that matters. So since the body of the arrow function sits here and it does not find any this, so it will basically again, resolve to global object. But for this say arrow goodbye function, okay, this fat arrow function, it physically sits here, right? So when I'll try to log this, it won't find any this for this arrow function. It will move one level up. And we have already seen that, for regular name, this will resolve to John. Okay. So this inside the say arrow goodbye will point to John. If it is not clear, please let me know. Even I know I fumbled a lot, and I tend to space out when I see champions in front of me. So if this is really important, if anyone wants me to explain it once, I'll be happy to explain it, and I'll attach the code sandbox link as well, so we can go through it anytime. And I have explained everything in the code sandbox, so it's super easy to go through it whenever we need help. So I'll just reiterate this once again. So basically here, when the say arrow goodbye function is invoked, this will resolve to John. Okay, and this is something that tends to confuse lots of developers, but this is so straightforward if we just go through these rules one by one. So basically, inside this scope, inside this function, this is pointing to John because of the way we are calling this function. Okay, with dot call, we have explicitly bound this to John here. So this here points to John. And since this arrow function is sitting right inside this function, and it does not rebind this just acts like, or lexically resolves like a regular variable, it will move a step up and it will get this. And if I call it with some other object, say James, then this will again lexically resolve to James. Okay, so these are just 6 rules, and I'll encourage you all to play with it and do some experiments with it. And in case you find some edge cases, please do post it in the JS Learn Club's channel, and maybe we can discuss it, and and the next session could be focused on those edge cases. Thank you so much for your patience. Thank you very much. Over to you, Sagar.
Yeah. Thanks, Vivek. That was really a great session.